pausing the video and reading the question thoroughly and trying this one. In particular, this one, see if you can do better than having to, in terms of efficiency, big O, do better than having to iterate through, for each one of these, iterate through this every time. So basically the big O of J times S, because for each letter we're having to go through this stones array every single time. Because the brute force method that does that, compares each letter in J to S, is fairly easy, and we actually will run through that real quick. But yeah, so go ahead and try that yourself, and we'll go forth, assuming you've done so. But yeah, so let's go ahead and start with that brute force simple method with the bad big O, inefficient big O. And we're going to use that syntax. Let's just say let answer equals 0. And we're going to say for each character in our Jules string, and it's going to require a for loop within a for loop, because we're saying for each character in here, iterate through here. And careful not to confuse these two variables. Name them different things, because when you have a for loop inside of a for loop, you can't use the same variable name. Let's see, h of s. And so for each character in S, if c equals ch, answer increment by 1, return answer. And just to show you that one works, I'm just going to grab this one up here. This is just the example. And let's run that. Let's see. And we get 3 as expected. Here. So this is fine. It works, but we are having to do, in terms of big O, J times S, because for each letter in J, we're iterating through S. So let's see if we can do better than that. Let's just keep this here. And let's read this whole algorithm. And the way we're going to do better is we're actually going to implement a, so we're going to use an object. Because objects are coded in such a way that they have constant lookup time. So essentially, what I mean is that we're using a hash table by using JavaScript's built-in objects. Because under the hood, they're coded in such a way that they are basically hash maps. If that doesn't make sense, I'll try to explain it a little more later, but when I do this, for example, I'm creating an object that has the hash map built in. So we create the hash map of the object, and we say for each character in J, we just want to store each character in J in our hash map, in our object. Just like that. So, oh sorry, we're going to set equal to 1. And I'll explain why in a second. Basically, we need that because, well, let's just show you what Jules looks like after we do that. So our Jules object after that would look like this. Oh. It's going to look like this because we're just setting the object, we're setting its key equal to 1. So for each of these characters, each of these characters are getting set to 1. So now that we have that, we can then access those characters in that object in constant time if we do for loop, and we say for each character in S, if so what we did there is we're saying for each of these characters, look in our object, and if we see that key, so if for the first time through, or the first letter, if A exists within this object as a key, increment answered by 1. And something important to note, this has-on property method, that actually, even if I did, so this doesn't actually have to be truthy, I could put null, and it would still, return 3. You can put anything here, it can even be falsy, and it still works out because this has a property method. All it does is looks for the key. It doesn't care what the value is. So it's just something to note. We can put anything we want here, but we're just going to put 1. And now our big O is n, because all we have to do is, or n plus n, because all we have to do is just jump through each array once. And yeah, hope you found this video helpful.